So thanks everyone for coming. So today we are supposed to look at differentiation 2. So you may ask yourself, what of differentiation 1? So we always begin by going through our syllabus book. Yeah, the one that is student friendly. Yeah. So we are going to first see what is supposed to be covered under differentiation 1 before I can literally introduce differentiation 2. So it is topic 10 and it's under, I think it is senior 5 term 2 work, topic 10. So under differentiation 1, as you can see, you first cover basic. So for the application, we have not yet reached there. I told you it's better we get basics first. Even differentiation 2 has very good basics. So by the time we start on applications, things will be very nice. But also applications, we are covering them this very holiday. So you should be very strong. That's if you have issues with any applications. Applications, they are these things of small changes. They are the things of rates of change. They are the things of maximum and minimum values. Yeah, so if you have issues with any of the three, that's under application and we shall cover them this holiday. But last holiday, we concentrated on basics, which I think we covered up to 90%. And this holiday, we are supposed to cover differentiation 2. After differentiation 2, we shall come back and get the application. So under application, under the basics, as you can see, you're supposed to derive the topic. You're supposed to talk about gradient of the tangent at a point. This one, I think we did only one example, but we shall do more when the application comes up. Deducing the basic rule that was in the introduction, the differentiation, product and quotient, functions, composite and chain rule, parametric, implicit, generating second derivatives. All these things were covered. So in case you have issues with any of these, provided I've mentioned something that is giving you a time, just under basic differentiation, make sure after this lesson or after this video, you make sure that you reach out to me, you get access to that work. So just to show you something small here, as you can see, I don't know if you people are in position to see my screen. I don't know if it is very visible. So this is our drive. So when I check senior 5 principal math, it's here. It is term to work. The topic is differentiation 1, it's here. So this is what was covered long time. So we had differentiation lesson 1, that's where you find all those things that were beginning the basic differentiation. Then chain rule was covered, it is also part. Then implicit, product rule and quotient rule were covered in one session. So you're sorted. Then we have parametric functions, which was lesson 4. So you realize that we are actually good to go. Yes, if you have looked at all those possibilities. So in differentiation lesson 1, where we have the introduction, you'll find all these up to the basic rule. You've seen product and quotient. It was covered, I think, with implicit. You've seen the composite. The composites were covered with chain rule, what we call the power bracket rule. Then parametric functions, it was lesson 4. Then generating second derivatives, we generated them at the end of one of those lessons. So out of the 4 lessons, I can't recall very well, but at the end of one of the lessons, that's when we covered second derivatives. So as we are going to differentiation 2, I don't want you to have questions. Why are we going to 2? Why are we jumping 1? We are jumping 1 because we covered the basics of 1. And what we are remaining with is applications, which is covered once when we are done with differentiation 2, which is a Form 6 topic. And I told you that this week we are introducing Form 6 work. So I think that is all. I can skip that. Now let's still go through our book and go to Senior 6, Term 1. It is here. Senior 6, Term 1 work. Vectors, we completed them last holiday. Still, if you have issues with vectors, you check out but it's a Form 6 topic, but we covered it last holiday. Yeah, so differentiation 2 is here, and it is our emphasis today, and we are following the syllabus. What the syllabus tells us to do is what we are going to do today. So it is topic 18, as you can see, Form 6, Term 1. So the very first subtopic, we talk about trigonometrical functions, and that's why we are here today. Nothing else. That's why we are here today. Then the second subtopic is exponential and logarithmic functions. This one will come in later because I guess, right, this is a lot of content, but we are going to go through it and see. So for today, according to the syllabus, they want us to review trigonometric functions. That means for today's lesson, if you have any issues with trigonometry, you may also be disturbed a bit. And that will have to mean that you're supposed to visit trigonometry first before you come for differentiation. So after that, we shall talk about the concept of limits and derivatives. Then they are talking of deriving things from first principles. Now, as tutors, we found issues with this syllabus book. Why? In basic differentiation, you've seen they didn't ask for first principles, but again in differentiation too, they asked. And you cannot teach first principles for trig without teaching first principles of the basic algebra. So we shall have a session for strictly first principles where we shall begin with x, we go to x squared, we go to 2x, we go to root x, 1 over root x, like that. As we come into trigonometry, as we go into inverse trig, as we go to exponentials, as we go to natural logarithms. You understand? So for today, this first one is going to be out, the first principles, and I've given you reasons. You cannot do first principles for trig, which is in differentiation 2. Yet we didn't do first principles for differentiation 1. It's not fair, you won't understand. And then as well, first principles in trigonometry need us to apply a lot of laws. They need us to apply compound angles, double angle formula, triple angle formula, half angle formulae, factor formulae, all those things, even expansion formulae at one point. That means we should be good students of trigonometry for us to tamper with the first principles in trigonometry. I think that person is called Gilbert. Please leave the screen. Leave the screen. I don't want you to act stubborn. So after that, the next thing shall be, so we are going to determine derivatives of trig functions, but without using first principles. Those ones will come. Then in the same lesson today, we are going to look at the derivatives of higher trig functions using shorter approaches like chain rule. We are going to see that. Then if time allows and you people are so cooperative, we shall also look at the inverse trig functions. Yes, where our main emphasis shall be on the inverse of these three. Yeah, I told you this is my own syllabus book. You cannot find it anywhere unless you hack my device, but it's only with me. So always use that chance to take the screenshots so that you can keep them for further use. But I'll release them in January. Yes. So I think that is enough introduction for the topic. When we reach this, I'll also introduce it very well so that you know the route we are going to follow. Then this third subtopic is Maclaurin theory or Maclaurin expansion. Then the very last one will be application. So the application of differentiation 2 is curve sketching. The application of differentiation 1 is the small changes, maximum and minimum values, then rates of change. So for me, I just teach applications at once, both those of 1 and 2, period. And when that is done, we shall have to go to integration 2. Now, integration 2, I don't know if you people are very ready, but this work is already there. I told you integration, there are 9 topics, and it was covered. So I don't know when you people are going to get time to watch this work. But just to show you something small, then we begin. That has been the introduction. That's how the first lessons be, because we have so many students with us. So it is a Form 6 topic. When I come here, Senior 6 Term 1 work, integration 2 is here. I don't know if you can see. The first lesson is there. lesson 1. Lesson 2, is it? I don't know. Maybe I removed it, I don't know why, but I'm seeing lesson 3, integration of trig functions using factor formula. Lesson 4 is integration of even and odd powers of cosine, and 5 is integration of sine and cosine substitution, 6 tan substitution, 7 natural log exponential, 8 tan functions and by parts, then the last one is partial fractions. So trust me, integration 2 is done. So the moment I'm done with differentiation 2, it is upon you to be serious. Go and visit integration 2, watch it on your own, at your own time, at your own convenience, and at your own pace. Hope you understand. So I've given you the sketch plan for calculus. Differentiation and integration are what they call calculus in math. So I don't expect any of you to have issues. Hope that has been sorted. So I think if I told you when you don't see the screen, you let me know. These are the lessons I've been telling you, the 9 lessons of integration. They are those ones under senior 6 term 1 work. I'm not repeating. In case you're not seeing what I'm saying, you raise up your hand. Those are the 9 lessons I meant. So after diff 2, you're supposed to come and watch integration 2 on your own. You're not supposed to involve me. I did my part and we recorded it. Long time. That's it. So we begin. So I believe you all know the lesson targets for today. So one, talked of the first one would be first principles, but we have said that these ones have been pushed for reasons I've explained. Then the second target is going to be going to look at the derivatives of primary trig functions, or what people call the standard derivatives. What people call the standard derivatives. So the primary trig functions, those who studied with us trigonometry, I told you the primary are 3, that is sine, that is cos, and TanX. Yes. Then, of course, after that, we shall also have to look at also those of the secondary trig functions. By this I mean secondary. Yes. And the secondary trig functions, I told you they are the cosec from sine, sec from cos, then the cot from tan. Those ones. Yeah. So they are called standard derivatives because they're even written somewhere. And I'm going to show you where that somewhere is at. So after us looking at that, we shall also look at the derivatives of higher functions. The derivatives of higher functions. By higher functions, we mean two things. By higher functions, we mean bigger or smaller angles. Then, by higher functions, we mean those functions that have been raised to certain powers. You people, as you write these notes, don't just write what I write, but combine what I say with what I write so that you come up with something big and serious. So, after us looking at that, we shall look at the application. The application of chain rule, product rule, talk of the implicit rule, differentiating trig functions. For people following. Those who know these things already. Yes. Basically that. The sixth one will depend if time allows. I remember telling you that when I write this, I mean differentiating. So I also want us to look at the differentiation of inverse trig functions if time allows. Inverse trig functions. But this is only and only if time allows us. And if people are understanding. If time allows. Yes. And that will be the end. So that's the sense of direction. Today's session. Yeah, you can take the screenshot. First principles have been pushed. I've told you why. So we are going to start with the standard derivatives. How many of you people have logbooks? How many of you people have logbooks? Seems there are those people who don't have. So let me share mine. I share with you the pages so that in your free time you can also follow up. Yeah? So let me share mine with the pages. Maybe when people buy their logbooks, they will follow up. So I'm sharing mine so that people in their free time they can. So those with logbooks, I want you to check formula. You go to mathematical formulae and go under analysis. Those with logbooks, I want you to go under analysis and check around formula 50. I don't know if you're seeing the table that has f of x, then the derivative of f of x. I don't know. Is anyone seeing that table? You can confirm with me the page. Yes, you can confirm the page in the chat if you're seeing that table that has f of x. Let me try to expose mine here. Someone is saying yes, page 63. Let's confirm. Is it formula 50? Is it the one? I don't know if people have that's the formula 54. 54. Yes. Let me hope the table that people have is a table that has a continuation here. Yes. The table that people have, so you people should be strong. The derivatives or the standard derivatives I'm talking about today, we have a table in the logbook that has all. So it is page 63, formula 54. Because for it proceeds and adds the secondary ones. So you will forgive my logbook. You will forgive my logbook. It has only the primary ones. But I know the one you have goes ahead and it puts for you the CosX. It adds the sec and quote. At least that I'm sure. Yes. So it adds the secondary ones here. Hope that's the logbook you have. So to take you back here, to begin, okay, that's what we begin with in simple terms. So first things first, they are the standard derivatives. So one, so as you begin, you can be checking the logbook as you perfect. But with time, after enough practice, things become obvious and you don't need to go and check again. So the standard derivatives, check in the math logbook. Page, people have said page 63. It is formula 54. It's not that every time you're going to be checking the logbook. So you should train yourself on how you can master these standard derivatives. You learn them by heart. You just accept that when I differentiate sign, I get cos. When I differentiate cos, I get negative sign. So I also alert you early enough that it's not that every time you're going to force yourself to check the logbook, because it may be stolen, anything can happen to it. So these ones, they are supposed to be learned by heart. Because no one will ask you, why is cos the derivative of sine? The answer is first principles. But is it that every time you're going to do first principles, you only do first principles when the question has asked you to? So you're not supposed to have how these derivatives are derived. You don't need. So learn them by heart and relax. So I'm going to take you through those who have logbooks well and good, but let's first go through everything as us. Then later on, you follow up. So we are going to have our simple table where we are going to have the function and its derivative, the function and its derivative. Yes. Okay. So we are going to have our table and say that this is the function. The function, then this side we are going to have the derivative. I want to remind us, the function in most cases, the function is written as y. In other cases, they write the function as f of x, meaning a function in x. If they use y and y is in terms of x, you all know that the derivative is written as dy by dx. I gave you a very good introduction of this topic. I don't want to over-explain. Those who have issues, you're requested to revisit the earlier sessions. Then the derivative, if they use f of x, the derivative is f prime x. So don't mix things. I don't want you to have f of x and then you do dy dx. I don't want you to have y in terms of x, then you write f prime x. So follow principles. So if our function, I want you to listen carefully. If our function is sin x, what will be the derivative? So we have 3 primary and 3 secondary. You're all aware. 3 primary, 3 secondary. You all know introductions of topics matter. You all know when we are done with the introduction, the rest becomes history. Yes. So you should be sober enough. So I think we have just one more column. Okay. Introduction matters a lot. So the first 3 primary, you know it is sine, cos, and sine, CosX, then tan x. Then the 3 secondary, you know from sine we have cosec, from cos we have sec, from tan we get cot. And I remember telling you why. Okay, now we need to know the derivatives. Just like you say that when you differentiate x, you get 1. When you differentiate x squared, you get 2x. When you differentiate negative x power negative 2, that you get 2x power negative 3. We need to know. What of sine? What if you differentiate sine? What do you get? Okay, now it's going to be very easy. When I differentiate, remember we are learning by heart. So first, put the brain aside. Let's now learn using the heart. You just accept that, yeah, that is it. When you're having sine and you differentiate it, you're going to get cos. You just accept. Don't ask me why. We are going to get what? CosX. So that means when you have cos, you will go back to sine. This time round, we are going to have a negative, and I will explain later. When you're having tan, and you differentiate it, you get sec squared x. Yes, that's what you get. Don't ask why. It's like telling you that if you're a biology student, it's like they tell you during competitive inhibition of an enzyme, the moment you increase substrate concentration, you will reverse the inhibition and you will increase enzyme activity. You just accept. It is okay. If it is a multiple choice question, you just answer. If you're a chemistry student, they tell you hydrolyze an alkene to get an alcohol. The explanation is a mechanism, but you don't need a mechanism at that point. The same thing here. Differentiate TanX, you get sec squared x. What does that imply? If you really want to know why, those are first principles, but they are not needed here. So that's what I mean by learning by heart. Okay. Now, these other ones are a bit sensitive. But we shall learn slowly. Now, I'm going to begin with this sec. Tan x was differentiated and we get, and when it is differentiated, we get sec squared x. Now, if it is sec x and we want to differentiate it, we get sec x tan x. The sec x comes back, it comes back with a tan. For some reason, our network is glitchy. So the students who are on, be sending prayer so that we don't get a lot of issues with our network. I'm really sorry for that and I beg your pardon. So I was saying that if it is now cot x will just copy tan x, but for it this time round it will be cosec. Someone may be like, but why are these things like this? I told you you're supposed to just learn by heart. You just accept. Period. I want to show you something fun here. But before I show you, let me first complete these derivatives. Maybe you'll connect after. For this cot, it will somehow resemble tan x, and it will be giving you cos x squared x, like that. This time around with a negative, and I will explain that also. Then this cosec, there is also a way it will resemble sec. It will come back just like the sec came back, and it will come with the cot along. But someone may be like, why does cosec come with cot along and sec come with tan along? And why does tan go to sec squared? And why does cot x go to negative cosec squared? Why do some have negatives? Why don't others have? So a lot of questions come up, but I told you the answers are in first principles. But you may not need every time to refer to the first principles. Not every question. You only do first principles when the question has asked you to. Now let me simplify your life a bit. I want you to first look at that table. You give that table time. The problem with this table, if you don't get it, even the higher questions we are going to do, they are going to be giving you a time. Why will they give you a time? Because you'll be like, I had cot, and then teacher is putting negative cosec squared. What is that? That's what I'm trying to avoid. So I'm going to give you 2 minutes. Look at that table, you pause a bit, close your eyes, look up, meditate, repeat after yourself like that. Don't worry, you're all muted. No one is going to listen to your meditation. Trust me, for us to apply product rule, quotient rule, implicit rule, chain rule in trig functions, you should know these standard ones. That's why they put them in the logbooks, because no one will examine them. They can only examine their first principles. And I told you why we are not doing first principles today. So you're supposed to know this first before you even think of learning higher things. So I'm giving you 2 minutes. You can even mute me, because me, I will not keep quiet. But I'm giving you 2 minutes. Look at that table. Make sure you understand it. It's what is going to determine this lesson and the next lesson of inverse trig if time doesn't allow us. But I want us to understand this. This is one of the backbones and hearts of calculus, because it combines a lot of topics. It brings trigonometry here, it brings differentiation here, it brings chain rule back, it brings product rule back, quotient rule, implicit functions get back, parametric come back in just this one topic. That's why I wanted to begin with it when people are not so serious and they understand that we are actually going to be so serious. I want only 5 people to tell me that they are done with going through. You know, I always want 5 people. 5 people. 5 people. 5 people only that you're done. By being done, I want you to ensure that by the time I change tan x to sec squared x, you know why that is happening. Think people are done. Yeah, why I ask you people to sit down, I want you to see that person who has understood. If you've not understood, you inbox that person. Zoom gives you that option of you inboxing a person. Yes. You ask them how you said you're done. Have you understood? Yes, give me your WhatsApp number. Private messages. You send them a private message so that no one else can see it. And that's how you get an academic friend. So make sure the lessons are interactive enough. So that is all. Now let me give you my hints. Let me give you my hints here. Those who attended with me, the very first lesson of trig we had, I think like 9 months back, we had what we called the 3 trig identities. I want to review them a bit because we also need them if at all we are covering inverse today, which I don't want. It will be too much. So I want you to recall that the first one was sine squared x plus that equal to 1. That was the first what? Trig identity. The second one was 1 plus tan squared x equaling to sec squared x. Then another one was 1 plus like that. I think people can recall that. Now, there is a way I used to understand the derivatives by going back to these ones. But I was just friendly with myself. I was like, oh, in the first identity, sine was with cos. That means when I differentiate sine, I should get cos. I want you to first listen. Then, of course, here we mean differentiating. Oh, then I be like, if I'm to go back, maybe I want to differentiate cos. That means I'll be getting sine. Remember, it is a negative, but I want you to wait. It's a negative, but let's wait. Then I was also like, oh, in the next identity, tan is with sec. Oh, then I was like, that means when I differentiate tan, I want you to listen. Sec must come. I know it is sec squared, but you first listen. Sec must come. Then when I differentiate sec, also tan must come. Oh, then I also added and said, in the third, cot is with cosec. Then I also said, oh, that means when I differentiate cot, I said, oh, cosec must come. Then I said, what if I'm differentiating x? I said, oh, that means cot must also what? Cot must also come. That's what I said. Back then, when I was also a student of principal math, I think it's like 11 years back. Then I said, sine cos, cos sine, that is fine. Then I said, but as tan is becoming sec, this sec come as squared. And also when I said when this cot is becoming cosec, this cosec will come as squared. But again, when it comes to the reverse, remember this is how the identity looks like. So the tan will just become sec. But if I'm going back, as the tan is coming, it should come with the sec. Like that. Like you're differentiating sec, sec must come, but it will come with the tan. But if tan is becoming sec, then this sec must be squared. Then I also applied the same thing here. I said quote, this is the direction, yeah? So as I'm differentiating quote, it will be that CosX squared. But as I'm going back, yes, quote must come through, but this time round I'm reversing everything. So the cosec must also come along, just like the sec came along. But the one of sine and cos was a bit different and specific. Then the last thing I added was, I said that every time I'm differentiating such, you know, that people can see that. I think let me use green. Then I also noted that every time I'm differentiating the trig functions that begin with CO, you know, people can see that cos, cot, cosec. I also told myself that I must put a negative. I must put a negative. I must put a negative. What did I do first? I wrote the three identities. What did I do next? I found out that differentiating each of them, the other must come through. After that, what did I consider? The direction of the identity. Tan just become sec squared. But as you're reversing, sec squared must come back along with the tan. I went to the third, the direction. If I'm differentiating cot alone, to become cosec squared. If I'm reversing, the cosec must come back, but it must come along with the cot. Something like that. Then lastly, I said all those trig functions that begin with CO, cos, cot, cosec, they should have a negative before. If that fails, then you go to your table, learn by heart. If you can't learn by heart, always carry a logbook to the examination room. That is the last resort. But I want you to have them in mind. Numbers will flow very well if you have these things in mind. So I don't know if that is a very okay page. You can take a screenshot of that. Yes. So we are beginning calculation. So when I start calculating, I don't want you to be confused at all. Yes. If you have any questions, always endeavor to raise up your hand. Or someone may, if you know you have that speaking tongue, you can always volunteer to be the chat secretary. If there is any issue that is pending and urgent, you raise up your hand. There are people who can't speak but can type. Yes, so you can help them out. So the table, you have all that direction. I gave you page 63, formula 54. It has whatever I've talked about and how you can recall everything. So we are going to start with example straight away. I don't want us to waste time, but there are things we are going to apply. If they gave you hard time before, hey, you're going to suffer. You are going to suffer. Okay. If you had issues with chain rule, you're going to face it rough. That one I promise. I promise. Questions are what you may call examples. So, of course, we are finding the dx. There is a way I want us to do these questions. We are going to do the questions in this format. You people recall that when they tell you on this side, I'm going to be having algebraic. In this side, I'm going to be having, whoever put that green line, you remove it from the screen. Don't want you to be stubborn. Thank you. Then this side we are going to have trigonometric. Okay, now I'm going to have here my 1a. I'm going to have here my 1b. So when a question comes and says algebra, is that squared? You just say dy dx is 1, something like that, because it is standard. So have it in mind that all the questions we are doing are asking us to find dy dx, nothing else, because we are dealing with differentiation as the topic. Then what if the question, what if it is y equaling to sin x? This one is also very easy. Just say dy dx. You all know the story is why we come up with CosX. So it is easy. You don't need to do any efforts. You don't need to do anything. Things are working out. Things are working out. Now, I want to ask people. Proceed. That has been number one. I don't want to leave anyone. When I leave you, please, you say it earlier. That, sir, doctor, you've left me. So I'll come here. Some of you in the future will become teachers and you'll have to come back and revisit this work. Yes, so make sure I'm your friend. Hey. So, number 2, part A and B. So I want people to tell me, what do we do when you're having something like this? X squared plus 1 power 3. Who can tell me, what do we do here? Because you need to first remember what is done. Yes, I'm saying Judy. Yes, Judy, unmute and speak. What do we do there?
What I think we do is that you lower the power, you write the power, then you rewrite the bracket the way it is, you reduce the power of the bracket by 1, then you differentiate what's inside the bracket.
Exactly. I don't know if people have heard. Judy has said that what you're supposed to do. So I taught this in chain rule. So those who may need to review, I will ask you. Yes, I'll ask you to refer. I'll ask you to refer. I'll ask you to refer to chain rule video, which I showed you at the beginning of the lesson, if you want to really revisit. But this is what she has said. She has said that as we are getting dy dx, first things first, drop this power. So you say 3. Then she said bring back this bracket, which is x squared plus 1. But bring it back with the reduced power. You understand? Which reduced power is a 2. Then after that, differentiate what is inside the bracket. When I differentiate x squared, I get 2x. When I differentiate 1, I get a 0, so no need of showing the 1. You understand? Then after you simplify your answer and say that dy dx is equal to that 6x, I don't know if people can see the 6x, x squared plus 1 squared, like that. If you have any issues with this, you're supposed to revisit that lesson. I usually don't repeat myself, but I give you a simple recap and I ask you to refer for further information. Hope that is fair. Now, what of the trig function? What if it is a power but for the trig function? Very important. And you're not supposed to take it lightly. I don't know if people really recall how this thing was done. Those days, I remember telling you that this is what they called the shortcut. Remember we called this the shortcut. But then it had a full cut, the long one. where you go through steps slowly as a mathematician. And you need those steps because even in integration, they are coming back. So I remember telling people, it is very easy because even this very lesson, we may need them. Let me just give you a simple recap. It being our first day, but I'll never repeat it. So the thing is y equal to, it is x squared plus 1 power 3. That is the question. Remember, you cannot expand it because even this one can be a power 5. Someone may be like, what if I just expand? What if they give you power 10? Will you really expand up to the 10th power? No. So, this is what I told you people. That when you see the function becoming more complex, you divide it into 2. If it is really becoming hard for you, you can select all this inside the bracket become a u. But I explained all these things in details in the lesson of chain rule. So you visit it. So remember telling you that you make that a u. So when you make it a u, please Raj, you remove that blue line. I don't want confusion. Thank you. So when you replace that thing inside the bracket with the u, this usually comes when this power is very big or very weird and disturbing. You get? So when it's such a power, when you replace it with u, that means your u is now the x squared plus 1. So the u has replaced x squared by 1. So even our y becomes u power 3. You get? Why? Because this u has replaced the x squared plus 1, which is here. So our y is a u power 3, and our u is just what is inside the brackets. But remember, the question is asking you to get what? dy dx. But you all know, those who attended with me, the introduction. I told you when you have s in terms of t, what you can get is a ds dt. When you have q in terms of r, what you can get, please Raj, leave the screen. I don't know why. What's the problem? You settle, you settle, you settle, you settle. Then if you have D in terms of E, that means, sorry, if you have D in terms of E, then you can get DD, DE. You get? When you have O, which is very rare, or theta in terms of alpha, then what you can get is DE, D alpha. When you have beta in terms of omega, you can get D beta, D omega. Like that. So when you split your question into 2, something up is going to happen. Let me first rub this off. People, you should befriend mathematics because at all levels of education you'll meet it. There is no course that escapes mathematics, especially algebra and calculus. They always come through at one point. They have a lot of applications. So you should appreciate them from day one. You get? So when I come here, I now know that I'm having y in terms of u. So what I can get is dy what? Du. Drop the power 3, reduce the power by 1, and that's how you come up with what? 3u squared. Very correct. Then you also come and say, you're having your u equal to that, u in terms of x. So what you can get is du d what? Du dx. Differentiate x squared, you get 2x. Differentiate positive 1, you get a 0. Now, what do you have? You realize that you're having dy what? Dy du, and you're having du d what? Du dx. But remember, the question is interested in dy what? Dx. It wants to see dy on top. Please, Mokwaya, you leave my screen. Then we have dx at the bottom. Now, I don't know why these people are disturbing us. Okay, thank you. So I remember telling you that we are having dy du and u dx, but the question wants us to get what? Dy dx. I'm explaining this for the first time. Remember, one of our achievements is chain rule. So it's like I'm covering it before even we reach it. And you know me, I'll just give you a lot of numbers so that I shift the blame to you and not the tutor. So I'll have set myself free. So you just realize that if you really want to get dy dx, we need dy on top. And what has dy on top is du dx. Sorry, dy du. Then we need dx down. What has dx down is the du dx. And you just realize that when you multiply those two, du will have to cancel. And when this du cancels with this du, I don't know if people can see how they will obtain the dy dx. You understand? That's what we are doing. I don't know if people can recall. And after you doing that, I remember we did replacement. If you recall, we said, dy du is 3u squared. Du dx is 2x. And then this one gave us 6xu squared. You get the point? That was our dy dx. But remember, u was not in these things. It is us who bisect and included the u. So after us getting what we want, we dump it. We use it and dump it, period. Use it, dump it. After getting the answer, now remove the u, put back. Remember, u was x squared plus what? Plus 1. So the answer is going to become, finally, the answer becomes 6x into x squared. You remove the u, but remember there is this squared. And who is Scully? Scully, I'm going to remove you from this meeting. I don't know why you're having a lot of excitement. I don't know. Seems you are ovulating, because that kind of excitement is common in ovulation, day 14 of the menstrual cycle. So the next time you do such a thing, you will face it rough. So that is the dy dx. So what I've been doing is the long cut, where I go through the splitting, introduce a u, come up with two functions, let them give us two differentiation coefficients. I don't know if people recall the three names, but when you don't call it dy dx, you call it a derivative of y with respect to x, or call it the differential coefficient. These are basics. When I start real numbers, I'm going to be very fast. So make sure you appreciate whatever is being done right now before it is too late. Then the other one was the shortcut, the one Judy gave us. Drop the power, bring back the function with the reduced power, then differentiate what was what given inside the bracket. You get? Drop the power, bring back what is inside the bracket with the reduced power by 1, then differentiate what is inside the bracket. That is the shortcut. Then a recap has been the long cut. Fix a u somewhere, come up with a u in x, then obtain a y in u. Get a du, get a du dx. Find ways of getting what the question wants, which is dy dx, by multiplying the two. You see the du cancelling and coming up with the dy dx. The u wasn't part, so after using it and getting the answer, dump it. Period. Hey. Okay. Remember we're on question 2. So I'll go to question 3. So I'll go to question 3. So question 3, I think people have something to ask. Yes, Christine.
Good morning, Doctor.
Yes, please.
Doctor, you didn't give us the derivative of sine cubed x.
Oh, hey, that's what I'm supposed to do. Thank you so much. Thank you, thank you. Yes, Abdul Salam, you have something to say.
Yeah, I was also asking why you have not done the part B.
Oh, sorry. Thank you, thank you. So this holiday I have people who are following. Eh, that's wow. So 2B is this. So before you do that number 2B, I want you to note. Before we note, I want someone to, let me put here a 3, then I put here 50, 50 degrees. I want someone who has a calculator to press this in the calculator and tell me what you get. Yeah, I want us to be very fast. Use 1 minute. Press the calculator, press that. Tell me what you get. Be genuine. What the calculator gives is what you're supposed to tell me, not what you think. And use one chance. Press. Before you press equal signs, first check. Is it really what I've pressed? Then press equal sign. Whatever the calculator gives you is what I want to see in the chart. Press it in the chart. Or you raise up your hand and tell me. Yes, I'm following in the chat. Hey, it seems people know how to press it. So no one is getting math error. All of you are getting values. I have syntax error. That's what I wanted. That's what I wanted. But some of you are just lying to me. Yes, me, I knew you had to get it. So first things first, the mere fact that this is a degree, that means your calculator should be in deg. That is one. Calculator should be in what? In degree, abbreviated as deg. Now I want you to understand that that one is written like that. Let me give you lifetime advice, lifetime mathematical guidance. Is written like that, but not pressed like that in a calculator. Yes, but not pressed like that in a calculator. So what should we do? So shall not that when you're having sine power anything n, then x, have it in mind that this is an overall power. Overall power, what do I mean? That the sin x is alone, then the power is what? N. Get the point? So this is an overall power to the function. This is an overall power to the what? To the function. Yes. You get it? You get it by force. What do I mean? Someone may be like, but still I'm not getting it. You're even making it worse. Okay, let me make it now worst. This is what I mean, that when you're having sine squared x, the squared is a power for the whole function sine what? Sine x. When I say tan power 4 to x, I want you to follow. Now, the angle is the what? 2x. But we have said that that ka power the ka 4 is the power for the whole thing. Tan 2x, then the overall power is a 4. Then, if I'm having cos power 3, and maybe my angle is a quarter x, like that, then this is now the angle. Please, Evans, you leave the screen. So that means that our function is cos with its angle, which is a quarter x, and then the overall power, which is a what? A 3. You know, people are getting it. It's not hard. Then lastly, if we are having sec power half, and maybe our angle is 5x, so that means the function is the sec what? 5x, and the power is what? Half. And you all know power half, the same as what? Square root. Yeah. Right now we are doing basics because we haven't reached where we are supposed to be. You will see that things are tough. I don't know why people are writing in the screen. Very disorganized people. So all of you in the chat, show me how we should write a quote. What is that one? Only that. Only that, then we resume. We resume with our part B. How do I write that? Before I go to part 2B, any trials? Yeah, people have understood. So you should know the difference. You should know the difference between the angle and the power. So the thing is, the function is caught with its power x over 2, and then the overall power is the 6. Yes, there are people who beautify their work and decide to put this angle in brackets. Yes, very organized people. Very organized people. They come here and say, my angle is x over 2. So when you use curved brackets here, these ones should be at least square brackets. And when you use curved brackets and the square brackets, the next thing you can use are curly brackets. They're okay in math. I can decide to come and now use the curly brackets here. Very acceptable. That is very okay. You can use square brackets. This is math, not chemistry. Okay. Now, for this number, I want us to use this part for the shortcut. For the doctors, those who don't want to waste time, those who want to become doctors. Then those who are going to become teachers, those who want to become teachers, they will use the long cut. They want to prove everything to students. What happens when you use the shortcut and then you fail along the way? That is communication for something. Okay. So the shortcut, the very first thing you're supposed to do is to rewrite and say this is the same as y, the function is sin x, and the power is 3. So as you're using the shortcut, it's very easy. We say for the shortcut, what do you do? Our facilitator for today, Judy, told us that if you're having a power 3 here on top, it's easy. What do? You get this 3, drop it, and I also drop it. Then she told us bring back this thing inside the brackets, so I've also brought it back. Then she said reduce this 3 by 1, 2. I've also done that. Then she said immediately differentiate what is inside the brackets. When you differentiate sign, you get what? Cos. I think you see why I told you that you need to learn these things by heart. Because we have reached a point where we need to differentiate sign. So does that mean we are going to use first principles? No. We follow our heart. And period. Then this one, and this one, you can summarize and see my answer is... Now you write back. It's better you rewrite it in this format. Why? I said it is written like that, but in the calculator don't press it like that. So provided you're writing it as your final answer, that one will be preferred. You like it or not. Hey. Now someone may be like, what of the long cut? If you want to use the long cut, power 3. So it's easy. This sin x is the u. You know why? If you have issues with any of that, make sure you visit the recording of chain rule. And just because I've not yet exposed the senior 6 work, but the senior 6 work is a lot. I recorded that work. That's why on the timetable you see there, work on the drive. You look at this timetable. Like for example, tomorrow morning it's supposed to be applied math. You're supposed to see normal distribution. And it is on the drive, so it's what you visit. All those who have paid, make sure before the day ends you have access to the drive, because tomorrow morning I may be a bit busy. Yes. Then tomorrow night we are going to do period 3 elements. Then in the afternoon prepare organic chemistry, alkyl halides. So the work is a lot. I don't know if people got a chance to look at normal distribution. Those who are okay with normal distribution, the drive has a lot of work. You realize Wednesday morning, we are also using the drive. And the topic is phase equilibria. Why did I put it there? I want the holiday to be used for ionic equilibria and we complete. So as I cover ionic equilibria, you cover phase. So if for you okay with normal distribution, for you can come here very fast and say, for me, let me go to Wednesday. I organize this timetable in a way that you can also use it to manage your time throughout the day. I left for you time before 10:30 for doing personal administration and house chores. Something like that. So let me hope you are set for whatever is coming, because this is the holiday where we are supposed to cover a minimum of 80% of the syllabus. We have the syllabus book here. So yes, we shall get a lesson where you are going to just be ticking. I come with the syllabus books, we get our drive. Is the lesson there, we tick. Is the lesson there, we tick. We count all learning outcomes. We count all what we have covered. If the learning outcomes, I last counted them when they are 4,000 plus. If we have covered around 3,000, we divide by 4,000 and multiply by 100 and get 75%. That means 75% of the syllabus has been what? Has been covered. And then what would you want from me? I will have set you free. Trust me, when you complete the syllabus in this holiday 2 months, you're going to enjoy senior 6. Because even when you fail a paper, you'll be like, at least I know these things, I can revisit. But the pressure is going to be too much. All pressure is going to shift to the candidates in all schools in Uganda. So make sure you use this holiday very well. cover work, make notes. If you don't make notes, you will not change. You'll have done nothing to your academic soul. So, hope I'm talking to the right people, and there is a word to a wise is always enough. So I've stopped there. So I'll come, and after us bringing our u, we have split that into two. That our u is now sine what? Then our y is now u power 3. People can see that. We are having u in terms of x, so what we can obtain is what they call du dx. Derivative of sine, you all know it is what? Cos. I'm having y in u. What I can get is divide what? Y du. Drop the power, reduce it by 1, like that. And it is very clear that if the question wants dy dx, when you get this and multiply it by this, don't you see that? That when you get these two and multiply them, this du is going to cancel with this du, and you get the dy what? The dy dx that the question wants. So what will you come up with? You will have dy dx equaling to this times this 3u squared times cos what? Cos x. But you all know this u alone, we let it to be what? Sin x. Remember, you're supposed to use it and dump it. So when you put there sin x, you get the same answer. Answer is the what? The same. I don't know what really people want. Split into two and everything. I think now I can go to number 3. So people tell me, which one is better? Shortcut, long cut, or both are okay, or both are hard? Which one do you take? Shortcut, long cut, both, or none? If you say none, that means both are hard. If you say both, that means both are okay. If you choose one, then that's what you prefer. Shortcut, both, shortcut, both, shortcut, both. Hey. Shortcut, both, shortcut, both, shortcut, both. Someone has commented what I wanted. Both are okay, but shortcut saves time. But shortcut can save time and as well save marks, if at all you are not easy. Okay. Number 3, another important concept. Very important. Very important. So number 3, we are going to apply the above concept. Now I had my people saying, most of you are saying shortcut, shortcut, shortcut. You tell me, what is the answer there? You tell me the answer to dy dx. Let me show you the power of a shortcut. What is dy dx? Let's see if really the shortcut is worth it. I'm waiting for the answers. People are telling me the answer is 1. Someone is saying cos 5x. You see, people have different answers. That means people are really benefiting. People are telling me 5 cos x, cos 5x. Hey, that means people are going to learn today. Yeah, most of you have failed. So most have failed. And because most have failed, what is the solution? The solution is to apply the above what? The solution is to apply the above concept. And how are we going to do the application? How are we going to do the application? Follow my people, look here. Remember telling you, the moment you see the question becoming very weird and disturbing, you split. Yes, you come, you get this one. Make it your YU. The angle alone. You can make that angle a U. When you make it a U, the question splits. The U is the 5 what? Then the Y has become sin U. Why is sin U? The U has replaced the 5 what? The 5x. Then you repeat the same things. Let me tell you, math is not hard, but it is made hard by students. So what do we have? We have dy du here, which is going to give us cos what? Cos u. Very correct. Then what are we going to have here? Here we are going to have dy du what? Sorry, du dx, which is a 5. Very correct. But remember, the question gave you y in x, so it wants dy dx. But you all know that when you get dy du, this one you obtained first. That when you get dy du and multiply it by du dx, you know what happens? This one will cancel with this, and you remain with dy dx, which is what the question what wants. So let's follow. Dy du is cos u. Then du dx is a what? A 5. So if you organize, the 5 comes first, then cos what? Cos u. But remember, this u is supposed to be used and dumped. Yes. Have it in mind that u is always used and dumped. You'd even see that in integration. U is always what? Used and dumped. After that, we are supposed to do replacements. Because the u was not part of us in the beginning. So we shall have our dy dx being what? 5 cos, and our u was what? 5x. But remember, this is the long cut. So we are getting our answer, which is coming from the what? From the long cut. So the question is, what is the shortcut? The question is, what is the shortcut? Because I believe people can sit down and do that long cut very well. But what is the shortcut? This is the shortcut. So all of you are going to be giving me answers using the shortcut. So when you have your y, and this is what most of you want, I know. If that is your y, this is what you do. differentiate this. That's what they call the angle. So I'll be calling it the angle. Differentiate the angle, because in most cases when you write cos x, that x is an angle. We all know trig. So differentiate it. What are we differentiating? The angle. So I'll say differentiate the what? The angle. After that, put it out. Put the derivative out. We are going to see what I mean by that. Then lastly, differentiate the trig function. Trig function, bringing back the original angle. Bringing back the original angle. Someone may be like, what do you mean? Why does it look hard? This is what I mean. That when you're having sine 5x, differentiate 5x and get 5. I want you to listen. Differentiate this 5x, which is the angle. Get 5. Put it out. What do I mean? 5. It is now out. Then differentiate the trig function. The trig function is sine. So when you differentiate sine, you get cos. Then do what? Bring back the original angle, which was 5 what? 5x. That is the shortcut, and it is accepted. Yes, it is accepted. But you also need to learn the long cut so that you're a real math student. But even the shortcut exists. Differentiate the angle alone. Put it out. Differentiate the trig function. If it is sine, make it cos. If it is cos, make it negative sine. But bring back the old or the original angle. As simple as that. So let's see whether people are getting me. And that's how I'll bring my 3b. This is what I mean. That when you're having sine, and this is 4x, this 4, as you're getting dy dx, first differentiate the angle. The angle is 4x. When you differentiate 4x, you get 4. Put it out. Differentiate the trig function, which is sine. When you differentiate sine, you get cos. Now bring back the original angle, and that is the answer. When you're having, let me go to 3c. When you're having y equaling to cos 2x, I want you to follow. And what do you want? You want dy dx of cos. You want dy dx. This is 2x. Differentiate 2x. What do you get? 2. Put it out. What do you have here? Cos. What's the derivative of cos? Negative what? Sine. Bring back the original what? Angle. And then conclude and say that, oh, my answer is negative 2 sine 2x. So that dy dx. My answer is negative 2 sine 2x, like that. And you're good to go. What if it's something different? Maybe you have your y equaling to tan, and this is 3/4x. It is also possible to have a fraction. Very possible. So this is your angle, the whole of this. So as you're coming to get dy dx, it is easy. You can use first principles as I've explained. Are you following? But you can say, let me differentiate the angle. 2x differentiated, you get 2. So anything, anyway, when you differentiate nx, you get n. 2x differentiated, you get 2. X differentiated, remember x is 1x, that's why you get 1. So when you differentiate nx, you get n. So when you differentiate 3 over 4x, you get 3 over 4. So you pull it out. When you differentiate tan, you get sec squared. Then bring back the original what? Angle. Like that. And it is accepted. Very okay. Very okay. Even when you use first principles, you derive to the same what? Same answer. Are you seeing why I told you need to learn the other table by heart? Because at this moment, it's not the transition from tan to sec squared that matters, but it's the rule of differentiating the angle, putting it out, bringing the derivative and maintaining the angle. So it's like tan to sec squared x, you've done nothing. So you just need to learn that by heart. Period. Now, number 4 is yours. Number 4 is yours, and I want 4 people. 4 people raise up your hands before I even put the numbers. So I'm going to put 4A, 4B. 4 people, I want 4 people. Put 4C and 4D. 4 people. So the first person you're doing for us, y is equal to negative cos. I think you do for us 7x. Another person, y is equal to cot 8x. Another person will do for us to sine 3 over 2x. And another one will do for us Are there 4 people? Yes. Ivan, you're doing A. Samsung, you're doing B. Ariela, you're doing C. Who is the 4th person? The 4th person is Philip. Yes. So when who is the first one? Ivan, when your time reaches unmute. Samsung, when your time reaches unmute. Ariela, unmute. And also Philip, unmute. Yes, Ivan. It's for Ivan. Someone called Samsung. This one is for Ariela. Ivan, please speak up. Or anyone ready, unmute. Okay, Ariela, begin. Ariela.
Oh, good afternoon.
Yes,
I'm
please,
not
good
so
afternoon.
sure of the answer, but see, when we differentiate the angle 3 out of 2x, I think you remain with 3 out of 2.
Yes, so you put it out 3 over 2, not so?
Yes.
Then
you differentiate the...
Then, wait a moment. Remember, we are having this 2 already,
Yes.
We are going to leave it out. Then we do our mathematics from inside here. Then you said we
Okay.
put 3 over 2. Then what next?
You differentiate the trig function.
Which is
When we
sine.
differentiate, yeah, we shall get cos.
Shall get cos.
And then you bring back the original angle. So that will be 3 out of 2x.
Exactly. Then the other magic is that this 2 cancels with this 2, not so?
Yes.
And then the answer becomes 3
3 cos.
of the original angle, isn't it?
Yes.
That is very correct. Thank you.
Okay.
Let me see who is ready and was chosen. Yes, Samsung.
Yes, sir. I'm just
Yes, Justus.
yeah. So number B for B, we have cot
So
x.
divide x.
So the
So
divide
what
x.
should I do?
So we are going to first differentiate the angle, which is it is x over 6, but that is a 60th, 1 over 6.
Yes.
So we write 1 over 6.
1 over 6. Remember, when you differentiate nx, you get n, not so?
Yeah. But unfortunately, we are having cot. So when you differentiate cot, when you differentiate any cot, the answer is a negative. So let us first put the negative behind the 1 over 6. So differentiating cot, we get cosec squared.
Cosec squared. Exactly.
Then we write the angle. That
Then
is
we
x.
bring exactly. And that is it. Things are not hard. Angle, differentiate it, write it. Differentiate trig function. Bring back the what? Not forgetting this car negative. Not forgetting this car squared. I try to give you my own way of learning it by heart. If everything fails, you use a logbook. So dear people, I think Ariella, no, not Ariella, I think it was the other people, the 2 people. Okay, anyone to help us with A and D? Who is ready for A and D?
Hello, I.
Yes.
Hello.
You're the one of D. You tell us, what should we do for D?
You mentioned the field, but I think it was Fifi JK.
Oh,
Then
why do you use hard names?
it's not hard. Differentiating this y equaling to negative eighth cosec 4x.
What
When you
should I do?
differentiate, like first of all, to use the shortcut, we are going to differentiate the angle, which is 4x, and we shall have 4.
We shall have what?
Then
4,
we
isn't it?
shall multiply it with the, and we shall bring negative 1 over 8 times 4 first.
Yes, now the best thing to do, you first put your negative 1 over 8 outside. Then you put square brackets. Then you start your normal things. You differentiate the
Okay.
angle. For x, you get 4. Now we are there.
Yeah.
What else should we do?
When we differentiate cosec, we get negative cosec
Negative, so
4x.
I'll come and put negative
Cosec
cosec
4x cot 4x.
cot for x, exactly like that.
Yeah.
Then I'll close
And
the bracket.
then,
So
yes,
then
here we have a negative. We have a negative outside and negative inside.
so it
And
becomes a
also the
positive.
the 8 will be reduced by a 4 to 2. So we shall have a half cosec 4x cot 4x.
Thank you so much. Yeah, that's it.
Okay.
So Ben Asma, you're going to do for us, but I think that's what you want. Where is Ben? You raise up your hand again. You people, those things of raising up your hand and again you disappear. What do you mean? Yes,
Good
Alfred.
afternoon, doctor.
Yes, Alfred.
Good afternoon.
Afternoon.
I would like to do good.
Yes. We proceed.
On doing number A, we
So what
shall
should I
first
do?
differentiate the angle, which is
Which is
7x,
7x. Remember, there is this
and then we
negative.
write
So I put the negative out and
yes.
I put my square brackets. Then I start doing my things. So you've said I put 7 because derivative of the angle 7x is 7. Then what?
Then we differentiate the sign.
The what?
When you differentiate cos, you will get you will get negative sign, and then the
Negative
angle.
sign. The original one, not so?
Yeah, the original angle.
Yes. Then, what next
Since
after
there
that?
is negative, when a negative multiplies a negative, you get a positive, and the
Exactly.
final answer becomes 7 sine 7x.
Yeah, that's it. Yeah, that's it. Now, we have talked of these things of angles, we talked of powers. But now, there is something very hard, and that is question 5. Mixed. What if they mix? Hey, you see, with A level, you may think you've understood, yet you've just appreciated. And appreciating is very different from understanding, very different from mastering. So I want to see that one person. How is this one mixed? It's having this angle, which is not x. What makes it mixed? It is also having this power. You can give it a try. Okay, write the answer in the chat. Let me first give people a chance. Write the answer in the chat. This one is a mixed case. You first write the answer in the chat. I first see. Let me first give people a chance. I'm giving people a chance. Write your answer in the chat. I see. It's a very hard number. Very hard. Mixed case. People are struggling. I'm seeing people with the plus. I'm seeing people. You see you see what the shortcut is doing? The shortcut is doing more harm than good. The shortcut is doing more harm than good. But it works. It works. It works. But I'm enjoying. People are struggling from the comment section. People are struggling. People are forgetting the 4. Some people are using AI. Some of you are not easy. You just paste it in AI, then you come and you look for the answer and paste it here. Hey, 24. Oh, squared. People are trying. Let me hope you people have books and pens, because these lessons are supposed to be interactive. Yeah, I think I've given everyone a chance to try. So I think people will handle the mixed case. So let me use the shortcut. Let me use the shortcut. People have struggled. People have struggled. But don't worry, we shall be there. People have struggled. Okay. Shortcut. Shortcut. Now, most of you enjoy the shortcut, but it is sensitive. So, this is it, people. How does the shortcut work? You first rewrite and say this is sine or x power 3. I want you to follow. Listen carefully. So we are using the shortcut. So I'll come and say dy dx. What am I supposed to do? According to the rule of shortcuts, I'm supposed to get this 3 and do what? Drop. So I'll drop. After dropping it, I'm supposed to bring back the sign for x. Are you listening? But as I bring it back with the reduced power. Then after that, I differentiate this. But differentiating sine for x, it needs me to first differentiate the angle which is for x. I put it out. The derivative of sine is cos. Then I bring back the old angle. So it is just one answer but full of stories, but in one line, and you get your mark. Then after that you simplify. Very easy. After that you simplify. Come and be like, your IDX is 3 times 4 is 12. Remember I told you it is pressed like this but written differently. Supposed to come and say sine squared, then 4x, then the cos for x, like that. I don't know if people had that answer. I saw some people having it, but still there are some people who didn't get it right. But I don't know if it is okay. But trust me, even the the long cut, it will bring it out. Now there are those other methods you may use to simplify your answer. And sometimes they may work. But that will come when we go into trigonometry. When the question has just told you write your answer, this is very okay. This is very okay, just because this answer is expanded, but it is marked correct. But there are questions that may later tell you to write your answer in some other formats. There's a question that may come and it wants you to remove this and put something else. But I will do that in trigonometry. If I may ask people, are people aware that that thing is the same as 1 minus cos squared x? Are people aware? This is 1. I'm going to put here a lot of things. Then you tell me whether you are aware. Are you aware that that one that I've circled is the same as that? Then you listen. Are you also aware that it is the same as a half into 1 minus no, if you are aware. If you are aware. So a question can tell you to do what they want. So this is 2 people. Then there's also this. I told you that the answer we have is very okay. But the person setting the question may want you to simplify or to convert your answer into something else. For example, are people aware that this one is the same as cos squared? Are people aware that that one is the same as this? Are people aware that that same thing is the same as 2 cos squared 2x minus 1? Are they aware it is the same as 1 minus 2 sine squared 2x? This must be covered in Trig. But why I'm giving all those options so that you are aware. In case they tell you to have a final answer, something that resembles any of those, you can substitute. But if you've been a student who does mathematics proofs, but that will come as we are revising trigonometry. Just don't worry. If any is confusing, just have a task of you going back to revisit or to make sure those things make sense. So these ones are like tasks. Find out why, how are they equal? Then this one is like a task. How are they equal? The same as those ones. All of them have given them to you as tasks. Then the last one from that very question. Yes, the examiner may be forced to talk about something like this. Remember in that very question, I'm seeing there sine for x. I'm seeing there cos for x. Are people aware that those two are the same as a half of sine 8x? Remember, this is non-differentiation too. Yes, we are differentiating trig functions, but then these are things that require you to be knowing a lot of trig knowledge. And it always comes, maybe you realize the question is asking you to write your answer up to somewhere like 8x. So that means you should have that knowledge of double angle. But these are things we shall look at. But I'm just giving you a task. And this is why we have premium groups. You should take such screenshots and post them. People have this knowledge and they guide you. They know how all these things come about. But in revision, we shall talk about everything. Just don't you worry. Yeah. I just didn't want to simplify that answer. Why? It has a lot of pathways. So where we are is very okay. In case the question wants you to follow this path, use that, like that. The question has 8x, you just know I'm taking this route. When the question is having 8x as the final answer it wants, you just know I'm taking this what? This route. If it is having cos squared, you just know I'm taking this what? This route which has cos squared. If it is cos squared to x, you're taking this route. If it is cos squared for x, you're taking this what? This route. So depending on what the examiner wants, you should know all the pathways. But the best one would be this last one. Yeah, it would be the best because it condenses. But even what we had here is very okay. So people, are we together there? Are we together with how you can proceed with that answer in case the question wants you to prove something? Have you gotten their device? You people, I've not told you to understand these ones now. Why the first one is equal to those ones, it is your task to find out. But I've been saying, we may not necessarily stop at where we are. The question may tell you, show that dy dx is something. So when you stop where you've stopped, trigonometry is very rich, in that it has compound angles, double angle, half angle, factor formula, and everything. So depending on where the question wants you to go, you're supposed to think from there, but that is another topic. So we shall be deviating, but just have it in mind. You can find out, why is sine squared for x the same as this? Why is it the same as a half and this? Maybe I can give you a hint and you can find out. This first task, I'm getting it from the first trig identity. The first trig identity. This second task, I'm getting it from half angles. Because you may develop pressure for no good reason, yet you have never covered half angles. I'm getting it from half angles. Yes. Then this one, the last one, I'm getting it from double what? Double angles. I'm getting it from double angles. So when you visit them, you will be in position to understand. Even this last one, I'm getting it from double angles. If you have issues, you visit that lesson we have of trigonometry. It is there on our drive. Trig 1 lesson, I think it has some of these rules. You can check on it. But our answer of dy dx, that's where it stops. But in case a question tells you, show that dy dx, you have to understand which path were they following. Are they following first trig identity? Are they following double angles, half angles, factor formula, such things? It's what I was talking about. But take your time. Take your time. It's not hard. Now, in case someone wanted to use the long cut I believe people now are aware. Yes, that when you have y equaling to sine of this for x, yeah, you can bring this, make it a u like that. But it also, yes, Fifi,
Doctor, sorry for interruption.
It's very okay.
But okay, like according to the timetable you had given us, okay, like just clear the break. I'm sorry for interruption, that's it. But I don't want to miss
break.
the lesson. Yeah, and there is something I had allocated for the break.
Hey, it's okay. Very soon we are going to end.
Okay.
Is this the first lesson you've attended? Seems this is the first one. The legends can tell you what may happen. Okay. So this one, same thing. You get du. You drop this 3. You bring back it with the reduced power. Then you differentiate. Remember, this one is looking like sin u with an overall power 3. So what you do, you drop this 3. You bring back the sin u with the reduced power 2, which is here. Then you differentiate what is inside the bracket and get cos u. Then this side, u is 4x. So du dx is a 4. To get dy dx, simple. Get du dx, multiply it by dy du. Then make sure you replace this u. Because the rule is simple, we use it and dump it. Use it and dump it, period. So I will not go into details of the long cut. So basically, here are the things I wanted. So more complex numbers, they are going to be done by you, not me. Because they just need you to have an open mind. Like a case in point, what do I mean by more complex numbers? It's you people who are going to do them, not me. You're going to say, I just want you to tell me they are doable. Doable, and that's all. Because even if I do a lot of numbers, what you need is the concept, and you all know that. I always give you the concept, I do basic numbers, I guide you on complex ones, you do them in your free time. Because you always have a lot of time as free time. I even put it on the timetable, and also your time at school. So what do I mean by complex numbers? For example, such a number. I put here tan squared, then I put here x squared plus 1 over 3. Is that number doable or not doable? Is it doable or not doable? You people tell me, is the number doable or not doable? Doable or not doable? Yes, you see those people saying doable. They are the people who are supposed to help you in case you are confused. Yes, part A you've said doable, then part B, doable. I want to see you attempting these numbers in your respective groups, those groups of booking classes. I want to see people trying. So if say 2 is doable, what of C? Is C doable? So you people, just to give you a hint, are you seeing this one? You're supposed to split it. You're supposed to split it and say it will become x squared over 3 plus 1 over 3. Yeah, that's the only problem I see. They're just splitting this. so that as you're differentiating it, you can understand that when this one is differentiated, it is a constant, it will become a 0. Then you handle this. That's the only thing I'm saying. Then this one is obvious. Differentiate the angle 3x squared plus 4x minus 4. Bring this negative sign, bring back that very angle. The whole of this is the angle. So it's not hard. So you need the basics which I've given you, but again, you need to do a lot of numbers. You all know that. I always don't do a lot of numbers. I want you to do that. So I try my level best to give you all the basics and principles. So you've said that is doable. Now there is this hard number, part C. You tell me if it is really doable. Don't lie to me. Is it doable? You people, is it doable? Is it doable? Is it doable? And the last one I'm putting is going to be E. As you're telling me those things that are doable, you're supposed to say the letter. I know people are taking notes, so people are going through the work we've covered. You people tell me that very fast. Is it doable? This is also doable. I've done it. Okay, let me go through your messages slowly. We're running with only one thing. We're running with only one thing. Let me see. Hint for C. C is doable. Trial, yeah, can be tried. Doable. Doable. What people are meaning the doables? Hey, these numbers are serious. But you just listen, briefly, because we are running with only one thing to end. I'm seeing more than 70 people. And you all know I usually end classes when people are less than 10. So when I see 70 people, I just be happy. But your candidates are supposed to endure. So this thing is very easy. Very easy. Because you're supposed to accept that it is like this. It is sine CosX And the whole of this is a squared, not so? So as you're getting dy dx, I don't know whether we are together there. So as you're getting dy dx, you drop the what? The 2. Then you bring back whatever is inside the what? The brackets. With the reduced power 1. Then after that, you differentiate this. But the question is, how can you differentiate this? People, I was so happy when people say doable, 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 doable. I was happy because I believe people know, they know the concept, they can play with those things of drop, what, and so on. But how are you going to differentiate this? That's the question. And I also want to see people saying their responses in the booking groups or the premium groups. You either tell me whether it is possible or not possible. If it is not possible, you tell me why. If it is possible, you do it. That is done. That is part C. Now about this one, part D, just rearranging. You realize it is tan this, and they'll set for you basics. These are called brain teasers. They'll set for you very easy things. So this is why in brackets we are having, or before we even bring brackets, our function is tan x squared plus this. This one is a power 3, but the whole of it is to power 4. You understand? So doing it will just require you to have an open mind, but there is no content. How? You bring this 4 and drop it, so you'll have a 4. Then you bring back the whole of that. With the reduced power, which is 3, then you differentiate what is inside. So how to differentiate what is inside, you know. You first differentiate the angle. Hey, you people, they are not hard, but they are just bulky. So they are there to just ease your mind. But let me brief you a bit with this part D. That you drop the power, which is a 4. Are you listening? After, bring back that whole thing inside, like this, but with the reduced power 3. After that, differentiate what is inside. But remember, for you to differentiate what is inside, it is done with this angle. This is the angle, isn't it? You're supposed to first differentiate that angle. Differentiating that angle, what do? You drop the power 3, you bring back what is inside with the reduced power by 1, which is a 2. After you differentiate what is what? Inside, which is 2x. And after doing all that, you have differentiated the angle and you've put it out. Now you're supposed to differentiate the trig function tan, which is sec squared. And after the sec squared, now you bring back the old angle. I don't know if we are together. Now the old angle sec squared, then you bring back the old angle. Now the old angle, I'm going to just put here old angle. The old angle is this thing, the x squared plus 1 all over 3. I don't know if people are getting that. So they're just brain teasers, but you use the same concepts. You just need to be doing a lot of things at the same time. Drop the power 4, bring back whatever is inside with the reduced power 3. Now differentiate what is inside. What is inside is tan with that angle. So you're supposed to differentiate So you're supposed to differentiate that angle and put it out. But also differentiating it is a long story. Drop the 3, bring it back with the reduced power, differentiate the bracket. Now differentiate the tan to a sec squared and bring back the old angle. So realize they're the same stories we have been saying, but it is just too bulky to confuse you, but it is nothing. So these are brain teasers. Don't worry, they will not set. Yeah. Then also this one, the same thing. If we just put this a quarter outside, when you put the quarter outside, what you will have will look like this. You will have your y, you will have inside tan of this plus 1 over 2, like that. And this will be a quarter. So to differentiate this, you simply follow the rules of the shortcut. Drop the a quarter. After dropping the a quarter, bring back the whole of this with the reduced power by 1. So you'll have negative 3 over 4. After reducing the a quarter by 1, then you differentiate what is inside. But what is inside is tan something. How do you differentiate tan something? First, handle the angle alone. Differentiate it, put it out. After putting it out, differentiate the tan to sec squared and bring back the same old angle. In one line, don't put anything like adding, no. In one line straight. Then simplification, I told you, that will be in revision of Trig. And we find out which is the exact path the examiner wants us to take. So I don't know if people are realizing that the complex cases, they are nothing. If I told you breathe in and out, and now say let me do this thing, slowly it can be done. So do people agree with me that we don't need to do a lot of numbers as far as these mixed things are concerned? It's about you people knowing the primaries or standard derivatives and you do everything. Do you see that? I want people to agree with me. Then we handle the last target. The last target, we just need 5 minutes because I wanted us to be off here by 1:30 so that you have your lunch. We meet again in the afternoon. So the remaining 3 minutes are enough for us to handle this last target. And I don't want to leave it. The last target. Yeah. Last target. Have people agreed with me concerning the mixed cases? Let me see whether people are agreeing. Do I have 5 agreements? Agreed. Agreed. Next one is in the afternoon. Oh, someone wants to take a screenshot. Okay. Yeah, but you need to go back and practice these things. I've left a lot of things. You need to go back. You need to go back and visit this work. We are now on page 8. We started from page 1 and a lot of math has been said. This is an introduction lesson. We should always agree and endure. If it is long, even if it is 10 hours, you're supposed to study. For the newcomers, we always have long lessons. Yes. Telling you that the lesson is 1 hour on the timetable, it is a trap so that you come and attend. Then I push you because you're a candidate and you're supposed to complete the syllabus this holiday. So you're not supposed to complain. That's why next week we have a lesson of 10 hours. 10 hours. Because there's something I want to complete. 10 hours from 8 p.m. to 6 a.m. in the morning. Even if I stay there alone, I will teach. So you let your friends know that. Okay. So I think the person who wanted to take the screenshot, you're done. So make sure you go back, practice again these cases. The lesson is going to be uploaded on the drive. And you're going to enjoy the revisiting. So the last target is the easiest. Why did I want to end with this? Because we are simply going to just review. We are going to simply just review product and quotient rule. Yes. So breathe in and out. Breathe in and out. I'm about to end. Don't hate studying on the last day. Review product and quotient rule. Review product and quotient rule. Why is it a review? I taught, and I showed you the video at the beginning of the lesson. So I taught, so we are safe. So I want to review product and quotient rule. Very fast, because you know them. Product rule is very easy. Is very easy. And it's what I'm going to begin with. So I'll come here and put product what? Product rule. Why is it always called product rule? That they give you a function y, and it is in terms of u and v. uv. So this uv, as you can see, it means u times v. So because of this times, that's why they call it product what? Product rule. Because times is multiplication, which is a product. You get the point. Then I remember telling you that u is the function. Okay. Okay, let's do this. Remember telling you that u and v are the functions because they are two different functions in x. So they are functions. The moment it becomes u prime or v prime, it becomes the derivative. I want you to listen. What I'm talking about now was considered in your sample papers of math. So listen carefully. If you don't listen, you will not pass. Because calculus is a full element of construct. So listen carefully. Why is uv? U and v functions. But the moment we put these primes, u prime, v prime, they are now called derivatives. Like after differentiating u, you get u prime. After differentiating v, you get v prime. Now we say it for product rule. If you really want to get dy dx, I'm not over explaining. If you want further explanation for product rule, you revisit the video. What do? You always keep one. Yes. Actually, this is a basic rule for both, yeah? That for both product and quotient rule, what do we always do? You keep one and differentiate the other. Keep one, differentiate the other. Yes. Keep one, differentiate the other. That's what we always do. Keep one, differentiate the other. Keep one, differentiate the other. Now you people know that product rule, we have said it is about multiplication. And you all know in multiplication, in mathematics, multiplication is a sister to addition, and the division is a sister to subtraction. At least you know that. Yes. Multiplication sister to addition, division sister to subtraction. You all know they always move together. So, for product rule, when you keep v, you must differentiate u. And when you keep u, you must differentiate what? V. And we said product rule is a sister to what? To addition. And that is product rule. You know, if people recall. But if you recall when v was written as dv dx, it is okay. Don't you remember when I told you that f prime x is the same as dy dx? Don't cram things. Just be a good student of mathematics who knows how these things come up. Then u prime is the same as du d what? Du dx. I told you that at the beginning as we are reviewing something. So, that was product rule. Then what of quotient rule? What's there? Those who started with me polynomials, you are aware that a quotient is the same as a division. That's why you have a divisor and quotient in the same place. So it is a division. You get? And you all know a division is a sister to what? To subtraction. So you're not going to be surprised. So why a division? So your area is given y. Yes, u and v come up, but this time round, it is a division. And for you to get dy dx, which is the derivative, differential coefficient, and others, is dy by dx. What do we always do? Keep v, differentiate u. Why? We keep one and differentiate the other. Then after that, you keep u, differentiate what? V. And you all know the divisions are sisters to what? Subtractions. So you subtract out of v squared. So that one thing that is so special about quotient rule is this division by the what? By the v squared. So don't also forget this. So you all know that one is the same as divide what? Dx. Practice and make it part of you. But if you feel like you can use it, but recording it is hard for you, it is there in the logbook. It is there in the logbook. It is there in the logbook. Because we have everything here. I don't know if people can see it here. It is hard to see. I've seen this one. It's the quotient, it is the product rule. They gave you two functions, small f of x and small g of x. Then they kept g of x and differentiated f of x. Then they added because of product rule. Then they kept f of x and differentiated g of what? Of x, as you can see. Then this one is the quotient rule. They kept v, differentiated u, then subtracted because of division, kept u and differentiated v, then all over v squared. So the logbook can be there. People can check those formulae. I think it is formulae 55, formulae 55, and 57. On the same page 63. Someone with the logbook, confirm with us. Is it 55 and 57 on page 63? The product and quotient rule. People may need it. You may read a lot of physics and biology, and time reaches when you cannot recall these things. But when you revisit, you can understand. But the logbook has some funny languages on some formulae which you may not get as a student. That's why it is advisable. Use teacher's formulae, do a lot of numbers, let those things become part of you. That is the best cheat code. That's the best cheat code. Nothing beats that. Nothing beats that. Okay. So, I think people have stamped in that it is 55 and 57 on page 63. So otherwise, you visit the logbook. Otherwise, visit the logbook. And people have confirmed with us that it is page 63, formula 55, 57. Yes. And me and you are aware. Of course, formula 55 is the first one, so it's the one of product rule. Then formula 57 is the one of what? Quotient rule. Yeah. So the review is simple. So now why are we doing all this, and where does our trig come in from? So how do we fix it in trig? That's when I will do for you I'm doing only examples. The examples here, we already have them. So we need like 2 minutes and end the lesson. 2 minutes and we are done. So as a candidate, you endure. So I will have y equaling to x squared sine 4x. Do you see these people? Yeah. You see that? It really doesn't need me to do anything. All is needed is you. Because I told you how trig functions are what? Differentiated, and I've reviewed for you product rule. So it is upon you to realize that, oh, so this is a u. Get the point? The last part of the lesson is the most important, and most people have left. Not actually most, but some. because I'm happy that we are more than 50. And then this last one is the v. Get the point? So it's up, do you know how to differentiate things well? If at all you know you have issues, please use the u and the v. But if you feel like you're perfect at product rule, just do things straight away. Straight away. But using u and v could be better, because in the end you will substitute. So suppose to come and say my u is what? X squared. When I differentiate u, what do I get? 2x. You stop there, you've sorted it. You come this side and handle v. What is my v? My v is sine 4x. What is my v prime? The derivative. We all know, differentiate the angle. When you differentiate 4x, you get 4. When you differentiate sine, you get cos. Then bring back the old angle. You get. Then after that, you come for product rule and say dy dx. What do? I bring v, I maintain v. And what is v? V is sine x. Because you have the details above, you just substitute. Then I differentiate u. What is u prime? 2x. Plus, I keep u. What is u? U is x squared. I differentiate v. What do I get? 4 cos 4x. If people are following, you see that? Then after you write the final answer and tell the examiner that dy dx, I'll begin with 2x. Then what? Sine 4x plus what? 4x squared, cos 4x. You get? Like, I've not done anything. I've just reviewed for you product rule, and I've used the principles you already have, and we've substituted and simplified our answer. And this is the answer, no need of even further simplifying. Why do you need to rewrite this or this? Now, that's where the other questions come in. Maybe they want you to proceed, which is very rare, because they also know trig is rich. So they don't always stress you. They just tell you get dy dx and stop there and go to the next thing. So nothing is hard here, really. Nothing is hard. You look at this number. You look at this number. So this has been. Okay. Now, you people, as you know, I always advise you to make sure that you make notes as I write. Because in most cases, I say a lot than I actually write. So it's always better you listen to what I say and what I write, then you make notes. Now, that was part A. Now part B, just product rule. Come and say, what if we have something like this? 5x cos squared x, like that. A number like that. So it's up to you to realize that this x, you can either say x or the 5x, whatever you want. It may can say, okay, can say my x. You people, which one do you usually use as u? What do you prefer? Do you prefer the whole of 5x or you prefer x alone? Because this one is obvious. The v is obvious, but I'm talking of the u. What do you always prefer? Do you prefer the whole of 5x or only x as your u? What do you usually use? If someone is saying 5 is a constant, but it is okay. It's okay. If you use 5 as a constant, you put it out. If you consider the whole of it, it is okay. Yeah. Okay, so we come and say the u is 5x, then the u prime is a 5, you get? Then the v is cos squared x, like that. Now you all know we are supposed to rewrite this and say brackets cos x with the power 2, like that. Then we come and say prime. Well, how do I differentiate? I write cos. Sorry, I drop the 2. I bring back the cos x with the reduced power 1. Then I differentiate cos x, which is negative what? Sin x, like that. A. Then what will I have? V prime to be negative what? 2 sin x cos x. You can leave it like this. Very okay. You can leave it like that. It is highly acceptable. But there is this math student who has just revised double angle. They can realize and say this is the same as negative sin 2x. I don't know if people are aware that sin 2x is the same as 2 sin x cos x. I think you people are aware, not so? So v prime is like negative sin 2x. You can leave it as the other one. You can simplify. With trigonometry, that's why later on I want us to revise trig. So that when you're revising more of differentiation too, it makes total sense. So after there, the remaining is just substitution. Just substitution. Because you already know its product rule. So you come and say dy dx. What do? I write my v. What is my v? It is here cos squared x. Then I differentiate u. What is my differentiated u? Is a 5, so I put 5. Because it is product rule, I will add. Then now I write my u, which is 5x, you get? Then I differentiate my v, which is negative. This is why I tell you that it is better you first do the u and v prime. U prime, v prime. Because when you reach this step, you're just substituting. And when they are marking, they come and just mark this, they mark this, they mark the addition, and they mark the overall substitution. Very important. Then after this, you just come up with the final answer. So dy dx shall have 5 cos squared x minus 5x sin 2x. Yeah. And you get the answer. You stop there. That is all. So you people realize that I don't need to do anything else concerning product rule. It's just a matter of you identifying your your u and your v. A case in point, is this number doable? Can you do that number? I tell you to find dy dx, can you? People, can you find dy dx when I tell you to do that? Can you? Yeah, people have said doable. Yeah, things are doable. Because for you, just come and be like this, the whole of this is my u. Then this one is my v. Then you substitute and try simplifying. Simplifying in trig doesn't matter because it is very rich. You can even stop where you stop where you want, unless the question wants you to prove something. But that will be done in revision. What we need now, can you differentiate u perfectly? Can you differentiate v perfectly? Do you know how to substitute in product rule? Can you simplify a bit? That is all. Good. I also want you to tell me, is this one also doable? If I come here and say, cosec squared 5x over 4, and I also add on another one, very hard, on cot 3 2x. Is it also doable?
You'll need to unlock your iPhone first.
Very clear. This one is the u, and this one is the v. So do you see that now this u alone it was the mixed thing. Remember the mixed things we are doing. This one, the v alone is mixed. Even this u alone is mixed. But they are now, so they are mixing two mixed things into product rule. And you know how to differentiate this, you also know how to differentiate this. So you just be playing around with substitution and trying to simplify according to your ability. So I don't see anything hard there. Can be tried. So you're supposed to try. You people, by doable, I mean they are the assignments. Those of you who are studying with me for the first time, I don't usually give assignments. I rarely, unless they are prepared. And okay, I give assignments in two ways. At the end of the lesson, we either take a screenshot for already prepared numbers or the doable ones. The moment I ask you and you said doable, that is an assignment. Don't think we just said doable and stop there. Every doable number. I think even those of last Friday were not aware. I came up with this rule during third term. For those students who do homeschooling with me, those who study from home and just go to school to do mocks and UNEB, they are the ones who know this. That every doable number, by doable number, I mean an assignment. So every doable number is an assignment. Yes, so at the end of the lesson, if I don't leave any work, have it in mind that whichever number we are saying doable, that was the assignment. Period. Okay. So quotient, I don't even need to do anything because it's the same as product. Guess what? Quotient, they will tell you y is equal to x squared out of sine 4x. You get the point? Not hard at all. We just tell them this one is my what? My u, x squared. So my u prime is what? 2x. Then you tell them this one is my what? Is my v, sine 4x. Then you tell them v prime is 4 cos same angle. So you have these 4. And the other ones you're supposed to substitute. But you're supposed to understand that it is quotient. So you need to know the right quotient formula before you flop. Okay? So what is the right quotient formula? You begin with the v. Where is your v? It is there, sine 4x. U prime. Which one is your u prime? X what? X squared. You understand? Minus, because of division. Which one is your u? You people. This is 2x, isn't it? Some of you are just accepting. We differentiate, like we kept v, so we had to differentiate u. Why? The rule is simple. Keep one, differentiate the other. Then write u or keep u. Then differentiate v. But remember, this is quotient, and that one special thing about quotient is all over the v squared. Which one is my v? My v is sine 4x, and I must do what? Square it. Then we write. We write and stop there. Don't do any other thing. Don't do any other thing. Unless the question tells you to simplify to something and you just lose like 1 score or 2. But it is usually 1. But why lose it yet you've practiced trigonometry? Okay. So this will be written as 2x, that minus, it will be 4x squared. Then this will be cos 4x out of, then you know that this one is best written like this. So these questions, someone may be like, but why don't we pull out 2x? Because it is common. Then when someone pulls out 2x here, I'm talking of this, here they will remain with only sine 4x minus. Then when you pull out 2x, this one becomes 2x, you get. Then cos 4x. That's if someone just decides to pull out the 2x. But even if you don't and stop there, you get your marks. You've substituted and simplified. Period. Why would you want to change this? No need. Have you identified U and V? Have you differentiated each? Have you substituted in the quotient formula? Period. Nothing much. And that's what they usually do. Hope we are together, people. So, I want you to tell me, is this one doable? You realize that I don't need to do a lot of numbers because you have the basics. People, is that one doable? Like if at all you have your U, this one is your V. Tell them my U is that one, sine 5x. Then you tell them my U prime is 5 cos 5x, because that one was taught. Then you tell them my V is tan x squared. Then you tell them when I differentiate it, what will I have? I'll have my 2. I drop the tan with a reduced power of 1. Then I differentiate tan to sec squared x. So you have your V, you have your V prime, you have your U, have your U prime. So you substitute in the quotient. So do you see, people, that we don't need to do a lot of numbers? Yes, I want us to, let me first plug in, moment. People, are we together? Do you get those things? Are we together? I don't want to leave anyone behind. Breather, you can take the screenshot. I think you need this screenshot. You can take it. By the way, people, it's better you be reminding me about screenshots every time I finish a page, so that you can do the needful. Every time I finish a page, you tell me I expose, something like that. Take a screenshot, even share. Every time I finish a page, you let me know you take a screenshot like that. So you people, trust me, this is nothing. It is nothing. Is this one doable? Is that one doable, people? Is that one doable? That one needs a lot of things, because you realize this one on top alone is product rule. Hey, this one alone is product rule. But again, the overall thing is quotient. So can you force your brain to do it and pass it? It is easy. You first do product rule alone. But the dydx of the product rule will be U prime for the quotient rule. You people, let me make this statement and you tell me whether it is right. In that number I've exposed, the dydx of the product rule it will be the U prime of the quotient rule. Am I right? On top, we are having product rule. But remember, on top, if it is quotient, it is a U. So the moment you get the dy dx of that product rule on top, it will be a U prime for the quotient rule. Are we together? But those are numbers just to make your brain sharper. They are brain teasers. I used to set them for myself those days, so that I forced myself to, because math is about just practicing, doing numbers and every time. You get? Hey. And that number is almost the same as this, though for it is product. But all those numbers are supposed to do them on your own. Can have x squared, then sin x tan x. Yes. And I tell you to find what? Dy dx, just to tease you. But realize there are 3 of them. So you first handle 2, which is product rule. But the dy dx you're going to get here will be a U prime for the second product rule, because I use product rule twice. Hey. But there are very rare cases, but numbers that are doable. Provided you avoid all possible errors, you can do them. And that is it. And that is it. And these ones have no, you can decide to, like this one. Someone else may say, if the number is like this, they have no order. Someone may be like, let me first apply product rule here. Someone can even rearrange and they begin with x squared with tan x. So for product rule, they have no order. But quotient, you have to do the needful. You have to do the needful. So basically, if I take you back to the syllabus, let's see here and see if we are really safe or we have just wasted time. For me, I knew, that's why I told you if time allows. Because I knew what the topic demands and I knew the time we are stopping, I knew we couldn't get time for inverse. Because people had no ideas. As far as first principles are concerned, you know what we said. But this, for the determining derivatives of trig functions, we have tried. We are done. What we have not done are first principles, and you know what we are going to do. Then higher trigonometry using shorter approaches. You all know we have been dealing with shortcuts throughout the lesson. So we have achieved that learning outcome perfectly. So the remaining part will be part C for the inverse. Now, this inverse is the one that has the application of implicit. But in that very lesson, I'll talk about parametric functions, but involving trig. Those of you recall when I was teaching you parametric functions, I told you that I'll bring trigonometry when we cover it in diff 2. Though for it was in diff 1. So if at all you want to understand the next lesson, I'm telling you facts. Requirements for the next lesson. So we only need just something small and we are done with this. Discuss subtopic of exponential and natural logarithm is the easiest and you will enjoy it. You will enjoy the next lesson more than any other lesson on this planet. Exponential and natural logarithms, they are the easiest because they bring back trigonometry, they bring back algebra, they bring out whatever we have been doing and they combine them into one thing, and it is always nice. So that one you are going to enjoy. So I'll give you the requirements for lesson 2. So the requirements of lesson 2 of differentiation 2, and why I don't want to always leave a lot of numbers is that you people have studied during an era where social media is very good and students are using it for academic causes. So after me teaching you differentiation too, you go to those WhatsApp groups you're in, tell someone, you send me questions of diff2, differentiating trig functions. You tell them, even send me scenarios if you have, so that you enjoy. Because you've started at an era where social media is there, students are using it very well, you should thank God for that. So the requirements are very simple. I just want you to revisit 2 videos. Only two. Revisit 2 videos. If you know them, then for you just wait for lesson 2, and it is very soon. The video of differentiating, I told you when I do DDX, I mean differentiating. What are you revisiting? You're revisiting the differentiation of implicit functions. You're revisiting the differentiation of implicit functions, and you're revisiting the one of parametric functions. And trust me, when you visit those, you will enjoy the next session. Yes. So those are the requirements for the next lesson. So our next stop, and I want to teach, I'll teach those things in one lesson. Our next stop, I'll teach inverse, because we don't have time. We are supposed to complete work, and I want you to go to integration. Yeah? So in the same lesson, I'll teach inverse, then the differentiation of exponential functions, and I'll tell you that's how they are written. Then in that same lesson, I'll teach differentiation of the natural logarithms, or the logarithmic functions. Remember, ln is natural log. I taught you that in numerical methods. The first lesson we had in your senior 5. So, and that's how they are written, and I'll explain more about that. And when we are done with that, the next thing shall be Maclaurin. Are you seeing this? Are you seeing this? It will be Maclaurin theory. And guess what? All of you look here. Maclaurin, remember I told you it is a senior 6 topic. So when I come here, differentiation 2. Are you seeing Maclaurin expansion? It is already there. It's either Maclaurin's theorem, theory, or expansion, or law. It is already there waiting for you. That's how I managed my time. I covered some topics ahead so that these topics I can cover and stop somewhere, but knowing where you're going is already there. And trust me, if you go and watch that lesson right now, if you've understood trigonometry, you can understand the Maclaurin's expansion, because it was full of trig functions. And it was also set this year. Even the previous year, it was set. So, you have a lot of things to do. Hey, I'm just making your way and I always give you a plan at the beginning of the lesson and at the end. So, hope you have realized. And after Maclaurin, the next thing shall be application, which I teach with that of diff 1. So, I'll put a stop on differentiation or calculus, and we shall attack something else, depending on how we are going to balance our time very well. So we meet very soon for alkyl halides. Just stay tuned. Remember, alkyl halides is supposed to start, I think, at 2:30, and it is 2:10. So I expected you to be having your lunch as we are in the evenings of the lesson. But I may also add you some minutes, 30 or an hour, then we begin. Yes. So you also be ready. Otherwise, thanks for attending. Those who have been on from the beginning, that's so nice of you. So that is the end. And I'll remain Paul Tutor. A science tutor, a science and math tutor at Science Scholars Academy, Uganda. Science Scholars Academy, Uganda. And if you really want to reach out, that is the number 27 95, 92. You can text, but for earlier response, WhatsApp calls are better. Otherwise, thank you for attending. I finally sign out. Any questions before I sign out completely? I'm not seeing people who are thanking me for the lesson. If you've not understood, you say it. Yes, the drive is coming immediately after here. Yes, immediately after here in the premium group. People are not thanking me for the lesson. I want to see those thank yous coming very fast, one after the other, one after the other, so that I feel important a bit. Yes, I'm going to communicate. Don't worry about time for the next session. Okay, so you have realized, always follow the syllabus book, and we have covered some good work, but you're supposed to practice a lot. Since we have a lot to cover, I always give you more basics and a few numbers and a few checks to see if numbers are doable. So you can't practice, otherwise you will not see change. And you're supposed to make your own notes, which you're supposed to follow up when you reach school, so that you also get things more. Hey. So, someone is saying I've not understood. These people who are saying thanks, you inbox them. And I'm also going to record this. This has been recorded. Yes, it has been recorded, so you're supposed to follow up later. Even after the recording and you don't understand, repeat it over and over. Period. Yes, so that is it. Someone is asking about the prices of our classes. You reach out to me. But as of now, they are 50,000 up to January. So it depends on when you're listening to this. Someone may listen to this in the future, 2028, when lessons are 500,000. So I wish you well, people. I think I've responded to most of your concerns. Otherwise, bye, and I love you so much.